Hi class, welcome to video number 3 on 45, 45, 90 triangles. In this video, we're going to do some more examples to build on our previous knowledge. And before we start, let's just review what we learned before. If we have a 45, 45, 90 triangle, this is an isosceles right triangle. Both legs would be the same, and the hypotenuse would be the leg times root 2. Okay, now let's put in place some rules. So it's going to be possible that we are given a leg and we are going to be asked to find the hypotenuse. So if we're going to go from a leg to a larger side, which is the hypotenuse, it would make sense to multiply. Multiply makes numbers bigger, and that's what we're doing in this case. So going from a leg to a hypotenuse, right? We're gonna take the leg, whatever it is, and multiply by the square root of 2. And since both legs are the same, you can just copy those. Now, what else could be asked of us? It might be possible that we're given a hypotenuse and we're asked to find a leg. So in this case, we wanna go smaller and we wanna do the opposite operation. So instead of multiplying to get bigger, we are going to divide to get smaller. So if we're going from a hypotenuse to a leg, we're going to take the hypotenuse and we're going to divide by the square root of 2. But we're going to also be careful to make sure that when we divide by the square root of 2, we multiply by our fancy 1 to get rid of the radical on the denominator. All right, so using these rules, let's see if we can do some examples. Example 1. So I'm given a 45, 45, 90 triangle. And a lot of times in these examples, you'll be given just one angle, but I always want you to make sure that you fill in the other one. It just makes things easier. And let's say that we're given that this side is 8. Okay, and the question says, hey, fill in all the missing sides. So fill in these other two sides. Well, we know the other leg is 8. And to get to the hypotenuse, since we're going bigger, going from the leg to the hypotenuse, we're going to multiply the leg times root 2. So I'm going to take the 8 and multiply by the square root of 2. Okay, that's easy enough. Now let's try a more complicated example. What if we had a 45, 45, 90 triangle, and we were given the hypotenuse. And the question said, hey, find the legs. In this case, if we're given the biggest side and we want to find something smaller, we want to divide. So going from the hypotenuse to the leg, we take the hypotenuse, divide by root 2, but we have to make sure to multiply by our fancy 1. So I'm going to take 6 root 2, divide by root 2. And in this case, you can see that the root 2's are going to conveniently cancel, making it almost unnecessary to multiply by the fancy 1. But we do have to keep this in mind in case the root 2's don't cancel. And in the next example, I'll show you an example of where you would need this. So here, the leg is 6 and the other leg is 6, okay? Notice again in the first example, 8, 8, 8, all match, all the same numbers, x, 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 and the hypotenuse has the multiplication by root 2, hypotenuse by root 2. Same thing here, 6, 6, 6, multiply by root 2. Okay, let's try this. Now let's say we're given that the hypotenuse is 6. All right, and that's all we're given. And the question said, find the legs. Well, to go down in size, we're going to divide. We're going to divide by root 2. But here, nothing's going to cancel, right? Because 6 and root 2, they're not friends. So I have to multiply by the square root of 2 over the square root of 2. This gives me 6 root 2 over the square root of 4. But this is 6 root 2 over 2, and we have to be careful. 6 divided by 2 is 3. So 3 root 2 3 root 2. Okay, and I want you to notice that even though the numbers don't look so nice, they still fit the same ratio. So 6 is really 3 root 2 times root 2. So the same concept still applies, right? It's just that the 6 looks a little different than in previous examples. All right, let's try another example. Let's try an example where the hypotenuse is 4. And I'm doing a lot of these examples because it's harder to go from the hypotenuse to the leg. It's actually easy to go from the leg to the hypotenuse, and I know you guys can do that pretty easily. So I'm purposely working on some harder examples for you. Okay, in this case, to go down, we want to divide. 4 divided by the square root of 2. And again, I have to rationalize and multiply by root 2 over root 2. This becomes 4 root 2 over the square root of 4. We know the square root of 4 is 2. And we have to reduce our fractions. 4 divided by 2 is 2. I now know that each leg is 2 root 2. Okay, I want to do one more example in this video, and then I think we're going to call it quits. I want to do an example where you have the leg, but the leg is a radical. So let's just come up here. Let's see if we can work out another example. I think this will be helpful in case you see something like this. Okay, so let's put the triangle here. And let's say we're given, let me make up a good number. Let's say this is 5 root 2. All right, so the leg you're given is 5 root 2. So the first thing you do is say, oh, this is easy. I know the other leg is also 5 root 2. Okay, now to go from the leg to the hypotenuse, we have to multiply, right? Leg to hypotenuse, we're getting bigger, so we're going to take the leg and multiply by the square root of 2. But this is going to look a little different, right? Because we already have a square root of 2 there, but it doesn't matter. We have to take the entire leg, right, and multiply it by the square root of 2. Now, in the last video, or in a previous video, we talked about how numbers multiply numbers and radicals multiply radicals. So in this case, the 2 numbers under the radical can be multiplied and the number in front will stay outside. So this is going to be 5 times the square root of 4, keeping that square root, right? Radicals multiply radicals. The square root of 4 is 2, 5 times 2 equals 10, right? So in the event that you have a radical in the leg, you know what to do. You know how to multiply radicals.